Hello guys, I am Vaishali Kikan and we are discussing chemistry. Today in this video we are going to discuss the chapter 5, that is the chemical processes. Today first of all we are going to start our discussion with the combustion. We are going to see what is a complete combustion and what is the incomplete combustion. What is a combustion first of all? Combustion is a chemical reaction in which a fuel burns in oxygen to produce combustion product and sometimes a flame as well. Right, so now we have two types of combustion, complete combustion and incomplete combustion. First of all, we are going to discuss the complete combustion of hydrocarbons. So here in the complete combustion of hydrocarbons, we have the combustion of the hydrocarbons in plentiful supply of oxygen. Right, we have a lot of oxygen and we are going to do the combustion in the lot of plentiful supply of oxygen to produce carbon dioxide, water and energy. So only three products are going to form: carbon dioxide, water and energy. So here we can have the hydrocarbon as CXHY plus we have O2. This O2 is plentiful O2 and enough O2 to now combust this carbon and hydrogen over here. Right, so this O2 can now oxidize carbon and hydrogen over here. It is going to produce CO2 in gaseous form plus H2O in the gaseous form plus energy. So only three products are CO2, H2O and energy. For example, we have CH4 in the gaseous form which is going to react with 2O2 to form CO2 in gaseous form plus 2H2O in the gaseous form plus energy. So here in the complete combustion we have most of the energy released. So if I compare complete and incomplete combustion, mostly energy is released in complete combustion, right? It will be having higher energy release as compared to incomplete combustion. It produces cleanest and hottest flame. The flame color would be blue. For example, we have ethane, which is acetylene. So acetylene will be producing a very high temperature sufficient to cut steel. So this is also called as oxyacetylene torch. Right, so coming to the reaction of ethane with oxygen. So here we have ethane 2C2H2. It is going in the gaseous form. It is going to react with 5O2 in the gaseous form to form 4CO2 plus 2H2O plus energy. So here also we have seen the products are CO2, H2O and energy. Now coming to the incomplete combustion of hydrocarbons. In the incomplete combustion of hydrocarbons, we have the combustion of the hydrocarbon in the limited supply of oxygen. Now here oxygen is not plentiful, it is not unlimited, it is limited to produce carbon dioxide, carbon monoxide, soot or water or energy, right? So we can have various products. We can have carbon monoxide produced, we can have carbon dioxide produced, we can have soot produced, we can have water vapors produced and obviously energy is released, right? So incomplete combustion is done in the fuel rich condition, right, where we have a lot of fuel whereas we have limited supply of oxygen. So limited quantity of energy is produced, which is sooty yellow orange flames, right? Sooty yellow orange flame would be there and the energy would be sooty. So soots are the carbon compound, so we are going to denote the soot as carbon. So soot are generally the unburnt carbon particles which are released during the combustion. It is used to start the gasoline powered devices such as lawn mowers, right? So in the lawn mowers, what we are going to do, we are going to do the incomplete combustion in the excess of fuel, right? So we will be getting fuel rich condition and we will be getting incomplete combustion. So here you can see the example where we have C7H16, the liquid form. It is reacting with 7O2 in the gaseous form to form 3 carbon. This is the soot plus 2 carbon monoxide gas plus 2 carbon dioxide gas plus 8 H2O, which is a water vapor plus energy. Now we cannot have only one type of reaction for the incomplete combustion. We can have more than one type of reaction as well, like C7H16. This is the same compound that is now undergoing the incomplete combustion in the presence of 11O2. It is going to give me 14CO carbon monoxide plus 8 H2O water vapor plus energy. Here you can see we have not produced the soot, right? We have not produced the carbon dioxide gas. So the products can vary in the incomplete combustion, right? So if I compare it with the complete combustion, in the complete combustion C7H16 in the liquid form, it is going to react with 11O2 in the gaseous form to form 7CO2 plus 8H2O plus energy. So only 3 products are formed, CO2, H2O and energy in the complete combustion. Now coming to the acids. Acid has a compound that produces hydrogen ion when they are mixed with water. Whenever we are putting acid in water, hydrogen ion are produced. They are going to form a solution that conduct electricity due to the hydrogen ion. They are going to conduct electricity. They taste sour. They turn blue, litmus red and neutralizes the bases as well. Right? So if I talk about HCl, which is an acid, HCl in aqueous, it is going to dissociate as H plus aqueous and Cl negative aqueous. Now coming to the base. Base is a compound that produces hydroxide ion, right? When mixed with water, it is going to form a solution that conduct electricity. Due to the hydroxide ion, it is going to conduct electricity. It tastes bitter and it turns red, litmus blue, and it also neutralizes the acid. So here we have NaOH. NaOH is going to give me Na positive and OH negative. So you can see we have the hydroxide ion formation. Coming to the pH scale. pH scale is a scale which is ranging from 0 to 14. It compares the acidity of solution. How much acidic the solution is, it is compared with the help of the pH scale. How much H plus ions it is going to emit, it is going to be understood with the help of pH scale. When I have a neutral solution, the pH is 7. For the acidic solution, pH is less than 7, and for the basic solution, pH is greater than 7. Coming to the properties of oxides, we can have now acidic oxide or we can have the basic oxide. First, let's discuss about the acidic oxide. Acidic oxide are the oxide that forms the acidic solution when they are dissolved in water. So as it is, they are not acidic, but when they are dissolved in water, they form the acidic solution. Acidic oxide are produced from the non-metallic oxide. Whenever a non-metal is reacting with the oxygen, it is going to form an oxide. So this is my acidic oxide. Like we have carbon dioxide. Carbon is a non-metal. Its oxide is now acidic oxide. It can be formed using the two reactions. First is a synthesis reaction with water, in which carbon dioxide, it is going to be react with water, CO2 in gaseous form plus H2O in the liquid. It is going to give me the carbonic acid H2CO3 in aqueous. Now carbonic acid is going to break down to produce H plus. Carbonic acid is not very stable. It is going to break down to form H plus and HCO3 negative. So here you can see, here we have the H plus, which is the acidic nature of the carbon dioxide. Now carbon dioxide is present in the atmosphere. Whenever water comes in the form of rain, it is going to react with the water to form the acid rain, right? Similarly, we have nitrogen oxide, which is produced with the help of first synthesis reaction with oxygen. So here it is produced by the burning of fuels in the engines of the vehicle. So first of all, it is going to react with the oxygen. So N2 plus O2 gives 2NO, right? This NO is my nitric oxide. Now this nitric oxide can be converted into nitrogen dioxide. 2NO plus O2 gives 2NO2, right? So here this 2NO2 is my nitrogen dioxide, which is produced from the nitric oxide. Now this nitrogen dioxide combined with water vapor. So 2NO2 plus H2O gives HNO3 plus HNO2. HNO3 over here is my nitric acid, HNO2 is my nitrous acid. So both of the acids are produced when I have the nitrogen oxide. So nitrogen oxide is again an acidic oxide. Now coming to the catalytic converter. Catalytic converter prevent oxide from the engine to enter the atmosphere. You can see again with the help of nitrogen oxide, we will be having the acid rain. We will be having the acids HNO3 and HNO2 in the rain. So which is going to convert the oceans into acidic nature. So we have to prevent it. How we are going to prevent it? Using the catalytic converter. Catalytic converter will prevent oxide from engine to enter the atmosphere, right? It is going to now have this nitric oxide, and nitric oxide with the help of a catalyst present in the catalytic converter. The catalyst over here is platinum, palladium and rhodium, right? So with the help of the catalyst in the catalytic converter, the nitric oxide is converted back to nitrogen and oxygen. Now nitrogen is connected, N2 is connected with the triple bond, and this is stable. So this is when this nitrogen N2 gas is formed, this is stable and the reverse reaction would be very slow, right? Now coming to the sulfur oxide. Sulfur oxide is again giving me acid precipitation, right? How it is formed? Using the volcanic activity or the fossil fuels, right? So fossil fuel burning like coal or crude oil burning is giving me the reaction where we have sulfur reacting with oxygen to gives SO2. This SO2 will be present now in the atmosphere. It is released in the atmosphere. This reaction with the atmospheric oxygen, this SO2 will now react with the oxygen present in the atmosphere to gives 2SO3. So 2SO2 plus O2 gives 2SO3. Now after that it is going to combine with water. SO3 plus H2O gives H2SO4. Now this sulfuric acid is the main component of the acid rain. Coming to the basic oxide. Basic oxide are the oxide that forms a basic solution when dissolved in water. Basic oxides are generally the metallic oxide, like we have the metal Na, sodium. With the sodium, whatever oxide I am forming, it's a basic oxide. So when I react sodium with oxygen, so 4Na plus O2 gives 2Na2O plus energy. So this Na2O is my basic oxide. So Na2O plus H2O gives me 2NaOH plus energy. So this NaOH is my basic nature. So here you can see with the help of Na2O we have formed a base. So it's a basic oxide. Similarly we have CaO, which is reacting with H2O to form CaOH2 plus energy. So here we can have the various basic oxide. Calcium over here is again a metal. With the help of metal oxide we are forming the basic oxides. Coming to the types of the neutralization reaction. So first of all we have neutralization of an acid, right? So hydroxide compounds or the carbonate compounds are used for the neutralization of an acid, right? So now we are going to discuss how the acids are neutralized with the hydroxide compounds and how with the carbonate compound in detail. First of all we are going to discuss the neutralization of acids with hydroxide compounds, right? So we have HCl. HCl is going to react with NaOH, so it is going to form H2O and NaCl, right? So HCl plus NaOH gives H2O plus NaCl. This is the reaction where acid HCl is going to react with base NaOH, right? NaOH is my hydroxide compound. It is going to form water H2O and the ionic compound NaCl. Right, so HCl can be dissociated and written as H plus and Cl negative. It has ions H plus and Cl negative. NaOH is having the ions Na positive and OH negative. So H positive is combined with OH negative to form the H2O. Now here we have the neutralization with the carbonate compound as well. How to neutralize an acid with the carbonate compound? Let's discuss this. We have the calcium carbonate. Calcium carbonate is present widely as the limestone rock, and it is also present in the shell of various animals as well. So calcium carbonate, when it is reacted with the sulfuric acid, it is giving me carbonic acid, and this carbonic acid is very unstable. It is going to decompose into water and CO2. So let's see the reactions. The sulfuric acid H2SO4, it is going to react with calcium carbonate CaCO3. It is going to form the carbonic acid H2CO3 plus calcium sulfate CaSO4. Now here we have formed a carbonic acid. Carbonic acid is going to get decomposed. So H2CO3 is going to form H2O plus CO2. Now here if I write the overall reaction would be H2SO4 plus CaCO3 gives H2O plus CO2 plus CaSO4. You can see here we are not having any of the acids, so we have done the neutralization of the acid. So we can write this equation as acid plus carbonate gives water plus carbon dioxide plus ionic compound. Now coming to the green chemistry in industry. So green chemistry in industry is the chemistry where we are moving in the industry level in the machines which are having the less toxic chemicals, and or we are going to go towards the equipment upgrade. Right, so whenever we are moving towards the less toxic chemicals, it is going to affect the production. It is going to increase the efficiency of the production, and also whenever I am going to get the equipment upgrade, it is going to again increase the efficiency of the production. Right, so overall, if I am going towards the green chemistry, it is going to reduce the cost of the production. Initially, the cost of the production will be increased by purchasing the new technology, the new devices, right, and the new machines as well. Whereas if I see in the long term, the green chemistry is going to give me the cheaper products. So green chemistry is manufacturing process where each step will be having the minimal environmental impact. Each and every step I am talking about. If I have an in-between step which is having a higher environmental impact, I am not going to call this type of chemistry as a green chemistry. But if I see overall all of the steps and all of the steps are giving me minimal environmental impact, then it is called as a green chemistry. It is also called as benign by design process, right? So we have various principles. We are going to talk about the 5 principles by which we can move towards the green chemistry. The principle number 1 states use renewable resources as the starting material. When we are going to move towards the green chemistry, we have to look for the starting material and we have to move towards the renewable resources. For example, if I talk about the raw material for plastic, plastic is made from oil. If I have oil is converted to benzene, which is actually carcinogenic, and carcinogenic means cancer causing. So benzene is cancer causing and it is produced from oil, and from the benzene we are going to produce the adipic acid, and from the adipic acid we can produce the plastic, right? So we can now convert this equation by now changing the starting product. We are now changing the raw material. We are now starting from starch instead of oil. When we start from starch, it is going to produce glucose. Glucose is producing benzene, which is going to produce adipic acid, plastic, and here we will be having a catalyst, E. coli bacteria, right? So here we have a concern also while moving to this type of reaction. You must have observed that we are moving to a different raw material, starch, which is renewable resources. It can be produced as a food also, but there is a concern also that we now require to produce a large amount of food for the energy purposes as well, and for the plastic purposes as well. So for the plastic production also we are producing food, for the eating also we are going to produce the food. So it is going to produce a large load on the food. So for the plastic formation as well as for consuming, we are going to produce the food which is going to produce a larger load on the food industry. So apart from that, we have the E. coli bacteria, which is now again a cause of concern for us, because it is not the bacteria which is present as it is now made by the various DNA changing techniques, right? So these two are the concerns with the principle 1 for this type of reaction. Now coming to the principle 2, where we are using the chemicals having less environmental impact. In the first case, in the first principle, we had changed the initial raw material which was renewable, right? So when we are changing the renewable resources, because oil is present in the limited amount, food can be produced again and again, we are reducing the impact on the environment. In the principle 2, we are using chemical which are directly having less environmental impact, like polystyrene is used to form the packaging product like fast food container or the styrofoam cups, right? So the liquid polystyrene is injected into a mold of container, and then we are using an expanding gas. This expanding gas mostly is used as a chlorofluorocarbons which react with ozones, and it can degrade the ozone, it can make the ozone layer thinner, and when the ozone layer will become thinner, or when there is a hole present in the ozone layer, the UV radiation will come to the earth, and these UV radiation can impact all of us. So what we are going to do, we are going to use the carbon dioxide as an expanding gas instead of CFC, which is non-polluting, it is cheaper, and even it is non-flammable. So this is how we have used the principle 2, and we have used a chemical which are having the less environmental impact. Now coming to the principle 3, we are going to use the catalyst to increase the reaction efficiency. The catalyst, I know that the catalyst is going to increase the rate of the reaction without getting consumed itself. It is going to speeding up the sulfuric acid production using vanadium pentoxide. So for the production of sulfuric acid, I am using a catalyst vanadium pentoxide. So here we are going to produce the sulfuric acid in the contact process, where the sulfur is passed to the roasting tower, which is passed to the oxidizing tower, then the sulfuric acid tank and from where we can get the sulfuric acid. So in the contact process we have 3-step process where the pure sulfur is giving me sulfuric acid. So you can see we have the 3 reaction here. Also I had talked about the 3 type of reaction for the production of sulfuric acid, right? So here we have a key step which is the slowest step, which is reaction of 2SO2 with the oxygen to give 2SO3. So this is the slowest step, and we can now increase the speed of this reaction by using the vanadium pentoxide catalyst. Right, coming to the principle 4, here we are going to use the lesser energy. So when I am going to talk about the manufacturing steel, with here this is the energy intensive process. And manufacturing steel requires a lot of energy, and here we want to do the updating of the aging equipment. In the updating, what we are going to do, we are going to use a more efficient blast furnace. Blast furnace is a better type of equipment. How? It is going to decrease energy requirement, it is going to decrease air pollution. Blast furnace is costly initially, but if it is used in long term, it is going to reduce energy requirement, reduce air pollution. So when the energy requirement is reduced, productivity is increased, operation cost is decreased, and when the air pollutants are less emitted from the blast furnace, so I can have decreased pollution handling equipment cost. Now coming to the principle 5. Principle 5 states waste not. Here we have the sulfuric acid batteries, which are the most hazardous substances, right? We want to recycle it, right? So Canadian battery recycler invented the recycling process where we can put the old batteries, and from the old batteries we can recycle into the new batteries so that it is not going to degrade or damage the environment. So this is called a closed loop process, because in the loop we are going to get the batteries again and again. It prevents hazardous substances to go into the atmosphere. Otherwise these batteries could have gone to the waste, and from there it can now damage the environment. So here we will be getting safe working condition, so productivity is going to increase, we will be having lesser pollutants, again the lesser pollution handling cost would be there. So overall I can say the green chemistry is going to increase the productivity, it is going to decrease the cost in the long term. Even if you are putting the equipment cost is high initially, the process cost is high initially, the technology change cost is high initially. If I see in the long term, the green chemistry is going to give me the cheaper products. So I hope you understood all of the things that I have discussed so far, and I hope you are going to meet me soon in the next class. Thank you so much.